All right, hey, I just want to go through what this lab is going to look at and kind of how you might walk through the procedure for this lab. So this lab is going to look at two spheres that are rolling down a ramp, and one ramp is going to be a little bit flatter while one ramp is going to be steeper. And let me walk through, excuse me, what we're doing with this. The main goal of this lab is just to start to understand something that is undergoing acceleration and what that actually looks like in terms of not only its acceleration values, but its displacement or position values and its velocity values. Okay, so the setup is I've recorded a sphere rolling down a ramp, and and so what you're going to do is just access each of those recordings, and then you're going to collect the data from those. So the steep ramp is this one. So we'll let that open up. And then what you're going to do is you're going to record the position and the time for every zero point 0.1 seconds of the sphere's motion. You're going to have to estimate the position to the nearest centimeter. So I don't want a half centimeters. I want either 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it has to be the minimum value we would know is to the 1 centimeter. Right? So here's an example of this first one. And so you'll see I start at position 0. And then what I have done, I'll kind of go back here. So feel free to pause the video. So what I've done is I've slowed down every 1/10 of a second. So if you look here, it's maybe at 1. It's not anywhere further than 1. It's barely had a chance to move. So our first few measurements should be pretty low, but it should change after our first few seconds or our first few measurements. So our second time interval will allow it to go. It should go to the 0.2, and I pause there for a second. So I'm going to make an estimate. Maybe that's at 3 or 4 or 5. If you need to, you can always pause the video. All right, maybe that's at 9 or 8 or 7, whatever you think. It should go to 0.4 now. Maybe that's at 12 or 14 or 15, whatever you think. All right. So you're going to do that for every 1/10 of a second. Okay, and you're going to build a data table that looks something like this: the time and the position on the ramp. Right? You're going to do that for both the steep ramp as well as the flat ramp. Right? So what you could do is you could have maybe down here you could say this is the flat ramp, and then we could do the same thing, and we'll name this one the steep ramp. Okay. To get a new tab, you just add a sheet there. That button there is going to get you into additional sheets. Okay. What you're then going to do is analyze some of this data. Right. So I know it's not super fun, but I think it's going to be helpful for us to understand what is happening. The first one is you're going to understand the displacement covered for each time interval. Okay. What that looks like is you could do it by hand, but you can also have the spreadsheet do it for you. So if I'm going to have the spreadsheet do it for me, I'm going to say equals, this one is just 0, right? And then this one is going to be equals, we're going to do our final position minus our initial position. So it's going to do that, B4 minus B3, and we see our displacement was 3. I can then take this and drag it down, and it's going to fill it in for me right away. So it's doing the calculations really quickly. So yes, the time to collect the data might be a little bit longer.
Hi, thanks so much for checking this out. My name is Mr. Ellis. Just wanted to introduce myself.
Sorry, a little bit longer than necessary, but we can do the calculations on the spreadsheet very quickly. So those are my displacements. Next thing it's going to have you do is now find the velocity for each time interval. Again, how we would do this is use our equation for velocity. So if this is my velocity in centimeters per second, my first one is 0, I can say my velocity equals my displacement. So I can do displacement divided by my time, which is 0.1. And I'm just going to type in 0.1 because notice for my next one, it has 6 centimeters divided by 0.1. I don't want to use 0.2. I want to use the time it took for that time interval. So from 0.1 to 0.2 was 0.1 seconds. And again, I could just take this and drag it down, and we get that to fill in very quickly. So we do our calculations very quickly. Okay. Then you're going to create 4 graphs: two position versus times, 2 velocity versus times. And so you can have either 2 graphs with both position times on one of them, or you can create 4 graphs, a position and velocity time for the flat ramp, a position and velocity time for the steep ramp. And then you're going to go through and answer these questions, right? And analyze the graphs, analyze the positions, the displacements, the velocities, right? And then at the very end, it's going to ask you to do the acceleration of each interval. And how we would do that is very similar to how we did the displacements. Our first one is going to be 0. Okay, our first one's going to be 0. Our second one is going to be equals our final velocity minus our initial velocity divided by our time, which again is 0.1 seconds. Oopsie. Divided by 0.1. We get 300. I'm going to drag that down, and I can get my accelerations pretty quickly from each of those. Okay, and then you can analyze that information. So that's how you're going to work through the lab. Please let me know what questions you have as you work through it. But it's going to help us start to look at what is true when something is going through an acceleration in terms of its displacements, its velocities for each time interval.